there is a set square. It has shortest side of length 50 mm. Set square, a 30-60 set square. So let's say this angle is 90 degree, this angle is 60 degree, so this angle is going to become 30 degree, and this is the shortest side which has got length of 50 mm. That side is resting in HP, so this is the resting reference. The surface is inclined in such a way that its top view is an isosceles triangle. Now we are getting a reduced view as a top view. Top view is projected in HP, so the surface is inclined to HP. Okay, so surface inclination is with HP, side is resting in HP, and the side which is in HP, that same side is 40 degree inclined to VP. Okay, so we get to know that it is resting on shorter side in HP and surface is inclined to HP. So to draw basic view, we are going to make it parallel to HP. So in HP we are going to get its basic view in HP, so that is going to be a top view. So solution is going to start from the top view. The shortest side, which is our resting reference, that shortest side we are going to keep at the left. Okay, so this is, let's say, A, B, C. Project all the points for the front view. The resting reference, that is the shortest side, it is located in HP, and to draw basic view we have made it completely rest in HP. So front view is going to appear on XY. So this is A dash, B dash, and this is C dash, and this is going to be our front view. Once you have located front view, at some random distance, let's locate A dash, B dash once again. Okay, I'll project that A dash, B dash vertically downward. Now the surface is inclined to HP, so I'm supposed to draw one line inclined to HP at some angle, but that angle is unknown, so I cannot draw this front view. So instead of front view, let's say if we can draw top view. So project the points for the top view. So this is going to be A1, this is going to be B1. Now what statement says, this top view, ideally what happens when we make that front view incline, this is step number 1, this is step number 2, and when we draw step number 3, we change the orientation of the view, and because of this change in orientation, when we draw step number 4, there is going to be reduced top view. Okay, so instead of giving this inclination, they have given shape that we are going to obtain in step number 4. What is that shape? It is an isosceles triangle. Isosceles triangle means its two sides has to be of same length. Now if you look at this sketch, the resting reference, that is side AB, same side we have drawn over here also. So this side is not going to change its length. This side is not going to change its length. Why? Because this side is in HP, so its length is always going to remain true length. So the isosceles triangle that I am going to draw in step number 4, one of the side is going to be 30 mm compulsory. If that side is 30 mm, so another side that I am going to draw, that also has to be 30 mm. So take the distance 30 mm and connect it with the A1, and that is going to be our top view. Okay, now project this C1 dash C1 vertically upward to locate the C1 dash. Now this front view and the front view that I am going to draw in step number 4 are going to be same. So I'll take that distance in a compass, we'll keep at A dash B dash and have intersection with this one, and this is going to be that front view. So this is C dash. Now this is the inclination that we need to find. They have asked to find the inclination with HP. The side A1 B1 which is in HP, that same side is inclined at 40 degree to VP. So from here at some random point draw one line inclined at 40 degree, and on that line locate this side A1 B1. The length of those two segments is going to be same, or the same view I am going to draw here over once again as that of step number 4, just changing its orientation. So this is a perpendicular side and this is another side, so that is going to be point C1. Now project all the points for the front view. Let me change the color. So this is projector through A1, B1 and C1. Similarly take projections from here also, and now connect the respective points. So this is A1 dash, this is B1 dash, and this is C1 dash. So this is one of the side, this is another side, and this is AC. So this is going to be our front view. Draw the projections of a circle of 70 mm diameter resting on HP on a point on its circumference. So let's say this is circle, it has got one point A on the circumference, and this point is resting in HP, such that plan is nothing but top view is an ellipse of minor axis 45 mm. The plan top view of diameter through that point A is making an angle of 45 degree with VP. So let's say I'll draw one diameter through that point A which is in HP. This diameter is inclined to VP at an angle of 45 degree. Okay, the plane is inclined to HP, but that inclination is not given directly. Instead of that inclination, they have given the shape that you are going to obtain because of that inclination, and from that shape we need to find the inclination value. Okay, so first you will get circle in a top view because it is resting on one of a point on circumference on HP. Surface is inclined to HP. So when you make that surface parallel to HP, true shape is going to obtain in HP, which is basically a top view. So once you get top view, split that circle into certain equal divisions. I am going to split it into 8 equal parts. So let's say these are the 8 divisions. 1 2 3 4 5 6 7 8. Project all the points for front view. Now it was resting on one of the point that is the resting reference on HP. In a basic view we made it completely rest on HP, so this is going to be our front view. So 1 dash, 2 dash, 3 dash, 4, 5, 6, 7 dash and 8 dash. Now at some random distance, first locate the 1 dash because that is to be kept on XY line as it is resting in HP. Now similar to previous example, instead of giving inclination of this line or the surface with HP, they have given the dimensions of the shape that we are going to obtain in a top view. So from that dimensions we are going to find the value of that inclination. So I'll erase this front view for time being because that we have not been given. Now what they have given, the minor axis is 45 mm, the diameter of the circle is 70 mm, and that is to be reduced. Now if you look at the sketch, this central there are two diameters that we can consider. This is the first diameter 1.5 and this is second diameter 3.7. So this 3.7 in front view is going to appear at the middle. So where either you lift it by keeping 0.5 on the ground, or if you keep that 0.1 on the ground and lift it like this way, here you will get 0.5 dash. In both the cases this 3.7 is going to be located at the 1 point, so that line is always going to remain parallel to HP. So in a top view its true length is going to remain unaltered. So when we are going to draw ellipse, this vertical diameter 3.7 is going to remain true length even in the step number 4, whereas the diameter 1.5, this one diameter is going to reduced. So horizontally take a distance of 45 mm and draw this vertical projector. Okay, project this vertically upward till it intersects. Okay, not intersects, let me erase that line. That line is not supposed to be there, we just have considered it. Okay, so I'll project this line at 45 mm vertically upward. Now this front view in the step number 2 to be drawn in step number 3 once again. So I'll take that distance in a compass, one center, and we'll have intersection with this one, and this is going to be the, so this is the theta that we have been asked. Now locate the remaining points also. So 2 dash, 3 dash, 4 dash, 5 dash, 6, 7, 8 dash. Project all the points vertically downward. Connect the intersection points. So this is 1 1, 2 1, 3 1, 4 1, 5 1, 6 1, 7 1, 8 1, and complete the ellipse. So you will get ellipse in this way. These points are to be on the ellipse. Now while drawing step number 5, next the diameter passing through that point 1, that is the diameter 1.5, and this is 1151. This is top view and this is true length. What they have given, top view of diameter is making 45 degree with VP. So we can directly draw this top view incline at 45 degree. So draw this line incline at 45 degree, and on this line locate this 1 1 5 1, and additionally locate the other points and complete this ellipse. Okay, so this is 1 1 2 1 3 1 4 1 5 1 6 1 7 1 and 8 1. Now project all the points for front view. Let me erase these things that we have written. Project all the points from front view as well. Now connect the respective points. So this is 1 1 dash, this is 2 1 dash, this is 3 1 dash, this is 4 1 dash, not this one, this one, 5 1 dash, 6 1 dash, 7 1 dash, and 8 1 dash, and connect all the points and complete the view. So this is the final view. A regular hexagon ABCDEF of 30 mm side is the front view of a plate when its surface is inclined to VP at 40 degree. Draw the projection when its side AB is in VP and incline at 45 degree to HP. Okay, now if you read this example carefully, this is basically step number 1, step number 2, step number 3, step number 4, 5 and step number 6. Why I have drawn step number 1 in front view? Because it's front view of a plate when its surface is inclined to VP. So plane is inclined to VP. To draw basic view, we need to make it parallel to VP. So the first step is going to appear in VP, that is in front view. So first step from front view, second, third, fourth, fifth, sixth. Now here what they have given, ideally what we do, we draw something in the step number 1. We draw its front top view, we make that top view incline, we take projections from this front view and this top view, and we draw this front view. Then we rotate this front view, take projection from this front view, projections from step number 3, and we complete this step number 6. Okay, now after providing some inclination in step number 3, that is the view that you have got in step number 2, that we are going to rotate. So after rotating that view and taking projections from step number 3 and step number 1, the view that you are going to get in step number 4, that view is a hexagon of side 30 mm. The side of hexagon is 30 mm. Okay, and why I have drawn this side at the left? Because it is resting on that side in VP. A regular hexagon 30 mm side is the front view of a plate when its surface inclined 40 degree to VP. Draw its projection when its side AB in VP. So resting reference is the side that we are going to keep at the left. Okay, so this is the resting reference, and in step number 4 we are going to get the hexagon. They haven't given what is the exact shape that you are supposed to draw in step number 1. This shape is completely unknown. This is hexagon, right? So this is hexagon that you are going to obtain after providing inclination. So when you make it parallel and then project, it is going to be something different than hexagon. So that is not hexagon, some random polygon that you are going to make incline and then you are going to get the hexagon. Okay, so let's draw the solution for this one. So in step number 2 you are going to get a hexagon of side of side 60 what is the dimension, 30 mm. So this dimension is 30. Now that is in VP. So one of the end is going to be on XY line. This is the another projection and this is projection of the midpoint. I'll name all the points. So this is A1 dash, B1 dash, C1 dash, D1 dash, E1 dash and F1 dash. So this is going to be A1, not A1, this is going to be A and F. Now this hexagon we have got when that plane was inclined at 40 degree. So from here I'll draw one line which is inclined at 40 degree and that line is nothing but our top view. So A, B, C, D, E and F. So this is the top view. Okay, this is step number 4, this is step number 3. Now we are going to reverse the process. We are going to draw step number 2 and we are going to make this side completely rest on the XY line. So I'll mark the first point CD, take a distance of AFCD in a compass. I'll locate that A.
Okay, I found this on the web for take a distance of a FCD.
So this is AF and let's say somewhere here I have got the point B and E, not B dash, B and E, and this is the top view. Okay, this is the top view. Now again reverse the process from the 3 process 2 from the view 2, locate the view number 1. So usually we used to project or take projections from view number 1 for the view number 4. This time we have projected that in reverse direction. So now this is A dash, this is B dash, this is C dash, this is D dash, this is E dash and this is F dash. So this is the object. It resembles to hexagon but this is not a hexagon. Okay, this is some random polygon, or you can call it as a irregular polygon also. Okay, so we have got step number 1, 2, 3, 4 now. Now let's proceed for the step number 5. To draw that step number 5, sorry, not here, step number 5, we are going to rotate this view. Now how we are going to rotate it? This side in VP. Which side is in VP? This AF, this is the resting reference. or this A1 F1. This is the resting reference. This side is inclined at 45 degree to HP. So draw one line which is inclined at 45 degree, and on that line locate this A1 F1. Okay, complete the remaining hexagon. So A1 B1 dash, sorry, C1 dash, D1 dash, E1 dash. Now project all the points for the top view. Project all the points from this front view. Connect the intersection points. So this one is A1, this one is F1, this one is B1, this one is C1, this one is D1, and this one is E1. As it is a hexagon, so connect all the points with a straight line, and this is going to be the final view.